On to logarithmic forms and converting them back to exponentials. Now let's solve for the power in example 1. To do that, you know that base is the arbitrary base. Power is the evaluated answer in the base exponential form, and the exponent's just being the exponent. So we're just converting back to its exponential form in example 1. Now in number 2, for log base 2 of 64 equal to y, just drag the base 2 to 2 to the y and set it equal to 64. 2 to the 6th power gives you 64, so y will be equal to 6. Now in problem 3, we have log 7, the base, absolute value of x plus 8, the linear factor, equal to 1. Now 7 has to be dragged to the right hand side to be the base, which the base is 7 to the 1 power, 1 being the exponent, and it's equal to the linear term x plus 8. Solving for x gives us negative 1. Note that logs can't be negative, or 0. Well, they're undefined at 0. Now, in problem 4, another literal kind of like equation, but assuming that a is to be constant. Now, base a is the arbitrary base of this log with the factor which is irreducibly a quadratic. Irreducible quadratic meaning z squared plus 4. So log base a of z squared plus 4 is equal to 5. Now if you convert that into the base exponential form, you have to the right hand side a to the 5th being equal to the irreducible quadratic term z squared plus 4. So solving for z squared, you get a5 minus 4. Remember your square root method, and z will give you that form. Double checking should prove true otherwise, as stated. Now, in the next example, the last one I mean, we have log, the base being r, little r, 10 is equal to 1 over 2. If we rewrite that, we have r to a fractional exponent power, 1 over 2, or the square root of r. Either way, it's fine, whichever way you write it. Take the square root of both sides. Then you end up with r being equal to 100. Now I hope these examples of logarithmic exponential form will help you on further problems. And the same goes for exponential to logarithmic forms in the previous video. Hope those will give you some good practice, and hope you enjoy learning more problems of these type of nature. Just note that when you have the solutions for the unknown variable, you can always double check by setting them back into the original equation and plugging them back in. Remember, if your left hand side and your right hand side are both correct, then you're all set. So this concludes conversions of exponential and logs and exponentials. See ya.